What are the biggest technical challenges the team has solved recently? And what hurdles are you currently tackling?
Thank you, Oleg, for that great question. Basically, recently, and just recently, I mean, we're always solving technical challenges, but as we'll see in the technical update, David implemented a new algorithm for finding the minimal and maximum solutions for Boolean equations. And Luca recently solved a difficult optimization problem with quantifier eliminations where he had to do extensive profiling of the code and finally was able to find the exact bottlenecks and resolve them. So that's really, something that we do every month. But yeah, thanks for that great question.
Hello, everyone. So this month, I've been working on finishing up the core features of point-wise revision, which is an absolute necessity for the demo, which we are working on. The main idea is that during execution, so like during the execution of a specification, there's now a dedicated update stream available in which you can write, and everything that's written into this update stream will be in a special way, namely using our point-wise revision algorithm, let's say joined with the current specification, so that in the next step of execution, you get, if possible, a fusion out of the two specifications in a logically consistent way. I think this took most of the month. For the usability of the execution of specifications, I have also implemented an initial type deduction algorithm. Yes, due to this type deduction algorithm, you no longer have to explicitly type input and output variables, but they can be inferred from constant types, where the tau type is assumed as a default type if now no type is found. Then another branch of work was the conversion of our recursive tree traversals to iterative versions, as Karim has mentioned, due to stack overflows which we were experiencing, because some of the algorithm used to solve certain logical formulas are not fully optimized yet, and for this reason, formulas which have certain shapes can explode so much that actually the recursion depth of those formulas becomes so huge that the stack memory is not enough to save the recursion trace. And for this reason, we ran into stack overflows. Now these stacks are carried out on the heap, and this is not a problem anymore. And somewhat adjacent to those tasks, I've been analyzing further performance bottlenecks and investigated where they're coming from. And this gives an outline on what I will be working on next month. And beside this, just usual bug fixes and general improvements of the code everywhere. And yeah, that's been my month. Thank you very much.
This month I've been working mostly in improvements on the solver related to the computation of the maximum and minimum solution. And also I've been working in the implementation of bit vectors. That means adding bit vectors as a new Boolean algebra into the Tau language. More precisely, regarding the improvements on the solver, now we use successive elimination to compute maximal and minimal solutions. And I have a test to check everything. And also I have made a few minor fixes in some of the commands that call the solver or parts of the solver. For example, the Lugenheim general reproductive system command. Regarding the implementation of bit vectors, I have started by just creating the grammar that we will use in the typing of constants, of bit vector constants in the Tau language. And also I have made a few changes in the Tau grammar so we could support arithmetic operations when dealing with bit vectors. Because at the end, the idea of having bit vectors is to have arithmetic, the possibility of computing with numbers in the Tau language. Apart from that, from the, let's say, the internal side of the Tau language, I have spec'd out the Boolean algebra for bit vectors, and the idea is to forward all the operations into the Z3 SMT solver from Microsoft. And I have made a huge refactor of all the parts that deal with how we work with Boolean algebras in the Tau language. In particular, I have split a lot of the code that we have in the definition of the Boolean algebra in such a way that it's easy to add more Boolean algebra, in particular that of bit vectors. And that's right now what I'm working is in adding the factories for the bit vector Boolean algebra. That means create the basic stuff to be able to work in Tau with bit vectors. And that's all for my month.